Hi all, welcome back to the Testing Mentor. Today we'll be discussing on how would we test a system that processes asynchronous jobs. Imagine you're testing an e-commerce platform. A customer places an order, but several things happen after the request completes, like confirmation email is sent, payment is processed, inventory is updated, shipping job is triggered. All of these run asynchronous background jobs. Now, the interviewer asks, how would you test a system that processes asynchronous jobs? If your answer is simply I'll wait a few seconds and verify the result, that's not what interviewers are looking for. Today, we'll break down the correct testing strategy senior SDETs use for asynchronous systems. This question evaluates whether you understand asynchronous workflows, message queues, eventual consistency, retry mechanisms, distributed system behavior. Modern architectures often use tools like Kafka, RabbitMQ, SQS, background workers. Testing these systems require different strategies than synchronous APIs. First, understand how the workflow works. Example, user to order service to message queue, worker service to process job, worker service to update database. The response to the user may return immediately while the job continues processing in the background. So, validation must happen after the job finishes. The biggest challenge with async systems is timing. The result does not appear immediately. Problems testers face is jobs processing slowly, intermittent delays, race conditions, flaky tests. If tests rely on fixed weights, they become unstable. A more advanced strategy is event validation. Instead of checking the database, you verify the event itself. For example, verify that the message was published to the queue. For Kafka systems, you can consume the event, validate the payload, verify downstream services processed it. This approach directly validates system behavior. Async systems usually implement retries. For example, if payment processing fails, the system retries. Your tests should simulate failures like temporary network failure, service unavailability, partial processing, and verify the system retries correctly. Sometimes retries fail completely. Messages are then moved to a dead letter queue. Testing should verify failed messages moves to DLQ, alerts are triggered, system does not lose data. This ensures reliability in production. Async systems are harder to debug, so observability becomes critical. Best practice includes logging job execution, tracking queue depth, monitoring job failures, measuring processing latency. These help quickly identify production issues. A strong interview answer could look like this: understand the asynchronous workflow, identify queues and worker services, avoid fixed weights in tests, using polling to validate final state, validate events in message queues, test retry logic and failure scenarios, verify dead letter queue behavior, use observability for debugging. This demonstrates system level testing maturity. Testing asynchronous systems requires understanding distributed architecture, event processing, and system reliability. That's exactly the kind of thinking interviewers expect from senior SDETs. If you are preparing for SDET interviews and want one-on-one mentorship, you can reach out to me. I've added my email ID in the pinned comment below. And stay tuned for the next episode in the Tricky SDET Interview Questions series. Thank you for watching.